Hey everybody, welcome to the third Gonka improvement proposal session. Thank you for joining. Just a few words before we start. This is the second session that is dedicated to the protocol changes. So today we're discussing big directions and long-lasting goals for the network and proposals specifically related to privacy and training. So these all are potential big architectural shifts that really need the full community alignment. So please get involved into these discussions. Those would be the long-lasting ones with a lot of iterations, a lot of intermediate milestones. Now, before we dive into that directions, a few words covering the previous session as well and the approach to funding different projects from community pool. So the last session that we had, the second GiP session, was related to the broader infrastructure and Gonka ecosystem. And these projects as well play a huge role in the protocol stability and growth. So they are still extremely important for the network in general. And luckily, those projects, they don't need major protocol changes. And teams can iterate in parallel without creating any bottlenecks. And we should, as a community, we should enable that iteration, not block it. So just like a reiteration of a thought that appeared on like different community meetings previously is that there's a simple math that if we deploy million USDT and like in the next month and only half of that delivers, we would still come out massively ahead. And if we would seed on this treasury and not decide where and who to fund and be very picky about those projects and be worried about what can potentially go wrong, well, then the expected value of the outcome would be zero. So let's use community pool as a fuel and not keep it in savings. And then funding many builders would allow us to iterate, try different things, and discover what actually works. So the speed of iteration here definitely beats precision of our selection, and a healthy rejection rate is great, but every funded dollar would recruit new contributors, new teams, new perspective, and that's what can really benefit the network as a whole. So let's keep that spirit going, both in the ecosystem projects and in see how we can make sure that in the long-term goals, we can also get to try as many hypotheses as we can, iterate and experiment so that we can grow and develop as fast as possible. Sounds good? Okay, I think in this spirit we can kick it off with the first proposal for today. Tamás will be presenting a proposal on the training implementation on Gonka.
Okay, fine. So we are going to talk about training. And Nastya, Gleb, David, feel free to interrupt me if you would like to add something or like maybe extend my arguments. So and this is going to be like a super like broad proposal, I would say, just to establish several principles and maybe give like an example of how this like development of training can look like. Everything, of course, is discussable, and I mean, this is not a detailed proposal. It's like a and like suggestion of a vision. So what does it mean to train something on Gonka? It means that we would like to use the hardware as a community, to use the hardware of the hosts to produce new machine learning models. And it like the fact that we are doing this in decentralized way with blockchain introduces some like limitations and possibly some strengths. So the first thing is that the training should be geo-distributed because our hosts are geo-distributed. If you would like to have like lots of machines training something, it's inevitable we're going to have machines in different locations in different countries. The second thing is this should be trustless. It means that if we have like a Byzantine actor, which means someone who is, for example, not doing the training work or doing some like data poisoning, training on some like spoiled data, uh, we should find a way to like exclude this participant from training, probably like don't give them reward, etc. And the third thing is that we don't have like a single point of control. So as a long-term goal, we would like to have a protocol which is not dependent on decisions of like any particular researcher or a group. It means that technically all the communications between the nodes are done through like decentralized, in a decentralized way. So they validate each other, no point of authority. So this is like three principles that are just inherited from Gonka itself. Okay, and there are a couple of like principles that I think we should have in mind if we are thinking about training. So the first thing is that the first principle is pluralism. It means that we don't want to have at least for the like nearest time one single training protocol which everybody should like practice only this. I think it's better if we have different ideas of how can we train a model on Gonka. We can have different teams or different researchers, different proposals of like what we can do here, and we should be able to support all of them technically. It means that if someone wants to do like, for example, full validation, everybody validates everyone inside the training loop. Another group suggests we should do probabilistic validation. Someone says like we should do something else. We should be able to support like different ways of training. The second thing is isolation. It means that we as training is like more of a R&D thing. We like do research. We try to understand how to train models on Gonka. We don't want training to be somehow destructive to the main processes like POC or inference. We would like to have training as a separate branch, probably even technically like separate container. Like for example, everybody has a training container that cannot somehow influence other like chain node or API node or ML node or something else. So we would like to have like isolated environment for training. And the third thing is gradualism. This is how I decided to call it. It's like as we start developing training, we may have different mechanisms and different like approaches to training. For example, like different ways of validation, different optimizers, I don't know, different like losses. But I guess that some of the approaches will be more successful than others, and slowly the infrastructure that was built for this kind of training by for by this like team can be integrated into more like main code, and we can say, okay, we run like these 5 experiments of pre-training, these 2 worked, let's make this kind of protocol our like common protocol. Only after like having an experience of training something we can bring it to the like to the common code, I would say. Gradualism means that we gradually like we do small experiments, we see what works, and what works we try to implement. Okay, these are the principles, and let's talk about infrastructure levels. So the most like the basic level, it's like the level on which we just give the technical ability to run something separate from inference and POC. I called it here a shards primitive. What do I mean by shard? It's like it's something analogous to the def shards by which inference is going to be scaled. But here it's like something like a training shard. training shard is like it can be as a first try, as a first attempt. It can be implemented just like dev shard. For example, there is a researcher or a group that create the like a shard that will do the training. This several hosts or several like ML nodes of different hosts, I get allocated to this shard. And then in these shards, what happens? Different nodes can, like, for example, run specific training scripts or download specific like data, everything that the group of researchers decided this shard to do. And before running this like training shard, of course, it should be somehow get validated and like approved by community. So the shards primitive is just, let's create two new like transaction types, create a training shard and like close a training shard. That's connected to the main chain, and everything that happens inside the shard, it is at least like early on, it is decided by those who like run the training. So I would guess that we can't do everything super decentralized like in the first, I would say, month of this development, and it should be reviewed by community. Okay, so this is like basics. Then we need like second layer is the training primitives, which means when we run training, we should have an ability to save and exchange artifacts like gradients or data or model checkpoints. We should be ready. We should be like ready to do the all reduce procedure, which means like the main like synchronization between different models, training in parallel on different machines, which we should be ready to evaluate some checkpoint on a specific data set. So this is a super basic like infrastructure for any training procedure. We should have it in a decentralized way. This is like the next thing. Then we have like, then we go into like specifics of training, what we would like, what would be great to have in training on Gonka. It's post-training tools. Like post-training of LLMs is usually largely done with synthetic data, and we have a huge like inference potential in Gonka. We can generate a lot of synthetic data. We can roll out the reasoning traces, and like using Gonka inference for Gonka training would be great. This is like another layer. The fourth is like we can create specific training environments, like for example, how usually coding agents are trained. There is a special container that can run different like Python functions, and the agent try to find the right Python function that will solve specific problem. So if we would like to train this kind of agents on our hosts should have this like training containers with the possibility to execute some code, and it should be all like safe for the whole machine. And the like fifth layer, this is something like long-term scaling, any like research ideas on how model can be scaled to like hundreds of billions of parameters. This is something like very, I mean, it's not like basic training infra. It's more about how to adapt the whole training concept to decentralized infrastructure. Okay, so maybe someone wants to comment on this or ask something. Okay, let's move on.
I think pretty straightforward. Yeah.
Yeah. Cool. So and this is the like possible way of going through different milestones. Each of the milestones can like bring the necessary infrastructure. I see it as possible like projects for the community. For example, like the first run project. We can have like 3 groups that everybody does their first run their way. And the idea of the first run milestone is that we have the basic training primitives here. But of course, before the first run, there should be like shards primitive. I will talk about this a bit later, but let's talk about training itself. So super basic things in training. It's like exchanging artifacts, monitoring, syncing the checkpoints, doing all reduce, etc. Something very simple. We don't have like high expectations of this model. We just want to see it like trained somehow, and it worked, and they didn't like fall on the hosts, and this is the first project. The second thing, the second milestone could be reasoning, because I guess training the reasoner will take us to generate a lot of data, uh, probably using the models that are hosted on Gonka, like Kimi or Quen. And this will bring infrastructure of data generation, probably distillation of the model. We will need to like generate, save, and store data somewhere. So solving these problems will lay the groundwork for the next trainings. The third milestone could be about reinforcement learning and specifically GRPO way of training. Here we can introduce this kind of like specific environments, for example, coding for models that can like search for a better Python function and then train by this like the successful attempts to find it, etc. And it can bring the infrastructure of like online generation of data on which we train, and basically just add the post-training layer to the training infrastructure. The fourth milestone is full training. Full training, I mean, using the whole, I mean, all the steps, like pre-training, for example, distilling this using the reasoning traces from inference, and doing post-training on some specific task like tool calling or coding or something else. And I think M4 means, M4 is the milestone which brings like actual like a lot of value that we can as a community train fully from scratch a model that can do this. Yeah, and the fifth milestone, I think it's like a lot of milestones, like how do we scale it? Maybe we can think of better ways of training neural networks, given that it will be on decentralized infrastructure. Okay, I haven't covered here the like shards primitives, and this is a like little sketchy scheme. I was like thinking about how it can work. As again, just as a first attempt, imagine we have a researcher or orchestrator. Researcher is the whitelisted user for which, for example, like get a grant on training, and researcher may run different training commands on the nodes that was allocated by the chain. So researcher interacts with the chain only with like a couple different transactions, like start training shard and settle training shard, and everything that's happens inside the training shard is like isolated. It does not communicate with the main chain. Again, the same as in dev shards. And inside the training shard, we have different nodes. For example, it's like allocated ML nodes from different hosts. We have the API container. And what can we do? Like researcher have a special library for training something. And we have like a set of basic commands that are needed for training, like to clone a repo, for example. A researcher have a specific repo which runs the decentralized training. Clone a repo, for example, or download data set, or synchronize gradients, or something else. It can be a broad set of commands, and like even like any bash command, for example. Maybe researcher will be able to run any bash command in a very self-contained and safe environment, which will be a train container. Or we can restrict the researcher to some specific like 5 commands. Yeah, and then researcher can like like run with the fast iterations of the training, having this flexibility. For example, if something in the code works not very well, researcher can like change the code, run the training command, like pull the repository and run a specific training script. So it's something kind of a restricted SSH access, something like that. So they cannot do all the commands, but they can do like some specific training commands. Yeah, and this is for the speed of testing different hypotheses, especially in the early stages. We see that if the researcher can do something, it's kind of centralized, because we need to trust the researcher that he will actually run the experiments. But I think that to build this kind of like 4 or 5 levels of infrastructure of training, on some stages we can like sacrifice full decentralization. Let's see if we have like 5 of those researchers that each of which implemented their own way of validation of how the training nodes validate each other, and there will be a successful one. And let's say for the next experiments, all the researchers should have this kind of validation mechanism, etc. So yeah, this is about the shards primitives. So let me stop on this slide and yeah, and have a discussion. And if anybody have questions, like comments, want to argue.
Yes, in the structure which you described in the end of the slides, yes. What are expected commands for the cases when a node behave in a malicious way?
In a malicious way. Yeah.
Like doesn't work at all, or because likely at this stage we will not have a formal validation, correct? Meaning that even if we expect from researchers to have some sort of validation, but we likely at this stage won't have it as a single standard.
Yeah.
What will happen if a node behave not in the way researcher would want them to behave?
Yeah, I think we could probably have at the like early on we can have researcher like being responsible for like saying to the main chain who did the work like honestly, who not. And probably it's a question of incentives, that researcher should not lie about that, and we should like trust researcher. But for example, if I'm a researcher and I try to train something and I see that node number 3, for example, always like falls and it doesn't work, I just will flag it in the settle shard command. I will say this node takes, let's say, 20% of the reward because I haven't seen it working. I think if we try to be super simple, this is the first way we can do that. This, I think, on the if we think about later stages, I think at some point in the training shards we will have some common mechanism for different training shards of validating each other. And this, of course, this validation, like long term, should be done by the whole training shard. For example, and there should be some like protocol of training should be fixed. For example, everybody should commit their gradient once every like 100 steps. If the specific node didn't commit their gradient, everybody like knows it, and then the whole training shard may commit to this like settle shard command or something like that.
Okay, just when I thought about this problem, I thought that due to on one hand, yes, we can rely on the researcher, but likely miners will not feel like fully comfortable for someone they don't know make a decision, unilateral decision of whether they get reward or not. So one of the solutions which I thought about is to give a special transaction to a researcher through which they can kick out some nodes from the training chart. And this will mean for them that they will just return to a normal operation where there are formal validations like POC and CPOC and like normal inference validation. So if they don't perform that, I expect that to have this as a punishment to have the kicking out from the training chart in just defaulting them to the regular protocol be a more kind of a level of punishment which we can give to an independent person. In this case, the miners won't be as concerned that researchers will have that flexibility.
Yes, got it. Yeah, so we don't give a researcher like an ability to like reduce the reward of someone. It's either they are a healthy trainer and they get their reward as a training node, or they are back to their like original to the main protocol. And yeah.
Yes, I would say that this is it sounds as a right balance, especially on the stages where, yes, I understand that the researchers likely on this stage will be whitelisted through governance. So it won't be like random people who can just, so they will need to act from their like real like identity. So in general, I agree that it's not as crucial, but still, miners usually are not as comfortable with someone have such a decision power. So it will be great to see like this type of a protocol in the proposal for training, I believe.
Yeah, totally agree.
Few words here. I think that's a very valid point, and exactly like the miners would be voting for this proposal. So I think that's like very fair to discuss with them during the proposal. But yeah, it makes total sense that in the very beginning there is a lot of freedom for, well, both the miners and researcher, and that we are pretty much like given up on some of the important things that we have for inference, like validation or like full proper decentralization. I think it's like very important to reiterate here why we're doing this, because there are several great teams that are working, great labs that are working on decentralized training, and most of them, as Tomas showed on one of the first slides, they specialize on some area, like either Byzantine robustness or geo-distributed training, and that the goal for us on the first iteration is to unlock those teams to like try as much as possible. And the thing is that at least like in my understanding, the constraints that we are setting up here from the protocol standpoint should be as minimal to require the researchers to make as minimal changes as possible to their like regular flow of deploying a training run if they have access to like a cluster or like they're renting some GPUs. So one important thing is like it should not be much harder, because then the overhead of starting a training run on Gonka would be too much of a constraint. And then as we evolve, obviously, like as the training runs grow and as the stakes here grow, we should be implementing more and more constraints on like how this is validated and how we ensure that exactly the work that was supposed to be done is being done. But yeah, I think that would be like a different branches of these discussions, but the like biggest short-term goal for us is just to unlock this work and like to unlock even the possibility to like make mistakes and learn from them here. Without obviously, yeah, without like any party suffering or like miners losing the rewards.
Yeah, I totally agree. I'm big proponent of the fast loop of iteration for researchers, as less friction as possible. I'm open to the idea of giving a researcher opportunity to run any bash commands in train containers, but we just need to put a lot of safeguards. Like, for example, if they have this train container, API node, which researcher cannot control, for example, can put firewalls. You can communicate only like with Hugging Face, GitHub, and your network of nodes. Nothing else you can communicate with, something like that. And put some watchdog, for example, a separate process that checks that train container doesn't consume too much memory or too much like GPUs, something like that. If we put a lot of safeguards, we can create a sandbox for researcher, just run any bash commands, and it will be super like really natural way of doing the research process.
Also, if anybody community wants to ask a question, feel free to also raise your hand and ask it, yeah, out loud. Or use the chat.
Okay, just to be clear what I think should be good next steps on training. I think we definitely see that in this discussion we have one is infrastructure question. So we should enable some first simple iterations. We should introduce some simplest primitives, and that we should probably done really soon, like in next months or so. And then it will be a lot of options, a lot of different experiments, which Thomas discussed and proposed now with how exact training can work, how exact validation should work. But yeah, I think for the infrastructure, we definitely need more refined details. Yes, we should define how such containers should be deployed. We should decide how such containers will be for sure reviewed before such experiments. We just run random container, it's impossible. And again, guardrails would not work that good for such containers. But that we can clearly separate work on this part and work on mainnet changes. If first we make these mainnet changes, as Thomas and Anastasia highlighted, iterations will be really short. And I think the main goal should be to enable these iterations and to enable many, many, many such iterations in parallel without difficulties of upgrade software on mainnet.
One thing I do think about is that we of course should not risk hosts that hosts take a risk that researcher will like somehow reduce their reward or something. That's why like for host it's a risk free. I think whether we should add some incentive, like if you are in training, if your node is in training, we'll like give you like 5% more weight or something like that.
That's probably just no. So if you're in training, if you are in, if not is in training, if researcher is satisfied how it works and don't kick it out, it doesn't require to pass CPOC, it doesn't require to serve inference, and yes, it's some additional grant. So it's more experimental, but in some way more safe environment, more without another risk of being punished. And if not is successfully training for full epoch, it's just definitely not will be punished for epoch. And that's probably just no risk, no punishment at all, but just opportunity to not be punished mechanism.
But as a training node, like it would be great if hosts are interested in maintaining their node that are in training. So for example, for me, if my node is like off and I'm okay, I'm going back to the main protocol. Like I don't need any training. And this is a risk for researcher to like quickly lose different nodes and nobody wants to do anything to keep their node healthy for the researcher.
Yeah, there probably might be some reward, but I think, yeah, so no risk, it's also some sort of, it's also good for miners. Okay, Anastasia, should we move to
Yeah,
the...
I think the exact amount of the reward is like a next iteration of this discussion, and definitely not just among like the small team speaking here right now. But yeah, let's Tamaz, if that's all that you wanted to share, I think we can switch to the next topic, which is related to privacy and specifically to implementation of trusted execution environment.
Yes, let me share my screen. Yeah, so let's talk a little bit about trust execution environment and what is the problem here and what we can do here. So yeah. Let's talk about inference in general and who has access to prompts, to response, and all user data which is sent on chain now. So first of all, it's host itself, the one who execute inference. Let's already talk in terms of dev shard, where there is no real transfer agent by design. So there is executor. Then executor for sure makes the execution and data is accessed inside ML node container. And even if chain adds any sort of encryption of this request when it's sent to executor, the host itself will still be able to access this data. Then once inference is executed, inference might be validated later by protocol. So during the epoch, another host can be sampled like, oh, they must check that executor did job correct. Yeah, if such, and for sure, such validator will have to have access to the data. Then there is a case when validator host found some issue. For example, it's assumes that inference is invalid. Then the challenge of such inference is triggered, and majority of hosts voting to mark such request as invalid by the whole chain or by the whole dev shard. So yeah, and they all should have access to this data also. In general, if restructure a little bit the procedure of validation, user can decide if user wants or if user doesn't want inference to be validated, and also if user want or doesn't want some validation, some inference to be challenged. The decision to show this data can be theoretically moved to the user, but yeah, will change a little bit design of network, but it's can be solved. But the problem is with current architecture, host executor still would have access to data. So again, any host can modify the software in ML node and just save the prompts to their disk. And it's possible. And let's consider how this data can be limited. Because if we want Gonka let's say, so in case when Gonka can utilize the GPU fully and Gonka is uh, stable, how to enable Gonka to be available for everyone, including some enterprise clients, including big companies, etc. This access to data by executor, it might be a problem because again, any miner can join Gonka, any miner can access this data. What if user cannot allow this, and if it's just for big companies, their internal policies would not allow this. Let's think how we can solve it and how we can enable using Gonka for any type of users. There are two real options which can be used for this. There's homomorphic encryption of in LLMs. There is quite theoretical thing. What if user will encrypt request and LLM will work with encrypted data and will produce encrypted output? And there are some success in this. So when LLM just doesn't see unencrypted data at all, there is some success in this area for smallest models, for really like demo cases. And that sounds really awesome. If that would work, that would be like ideal. Everyone can host, no hardware requirements, and host doesn't have access to data. That sounds awesome, but unfortunately, right now, that's huge performance overhead, like 100 times in many cases. And also, it's impossible to scale to big models in current state of this area. And we don't know, no one knows if it will be possible in the future. So that sounds good, but can't not good enough for production usage for now. Another quite big area which explored quite a lot in recent years is trusted execution environment. So we all know Intel, AMD have this technology in their CPUs. So essentially, there are different ways how it can work. Sometimes it's guarantee for specific application, something it is guarantee for the virtual machine on certain server. But the idea is that CPU has some private key in protected area of hardware, which is really hard to access. And this key can be verified against public data published by Intel or AMD that it's real pub key for this CPU. And then software allowed to launch some application which then machine will check which exactly software is used in this application, or in case of virtual machine, what exactly was state of memory when such virtual machine was loaded, and then it can, from hardware side, produce certain certificates that, oh yeah, that's exactly this application loaded on this machine and with this hardware and with such state of memory on launch, and it's signed by this hardware, this private key, which is in CPU. Then such machine cannot be, if software is correct and don't produce any artifacts on disk, it can act in the way that full RAM of such application will be encrypted and will be encrypted by this private key. And even if just physically try to read bytes from memory, it still will be encrypted. So it's almost impossible, if no uh, if the private key is still secured and no bugs, it's essentially impossible to read data from memory. Yeah. And essentially all user data can be in such memory, and essentially all new GPUs started with H100, H200 of NVIDIA added that technology confidential compute, which can join such one type of such trusted execution environment, which names enclave, and it's virtual machine level trusted execution environment, and then all data in memory of GPU will be also encrypted, and such certificate can also prove that GPU is added to this enclave. Yeah, what's essentially this means? Chain can support additional type of ML nodes which support this technology. What does it mean? That the full ML node is loaded inside such enclave, such virtual machine with certain guarantee from hardware and certificate provided. Then it will require definitely modification of ML node software, that no data ever recorded to logs, no data ever recorded to disk. And then once such ML nodes virtual machine created, it can produce certain, and such certificate can be published on mainnet, and then everyone can verify it against public data published by Intel, AMD, NVIDIA, etc. Yeah. So again, it can be optional. It definitely don't need to be required on all ML nodes in network. It definitely should be virtual machine level trust execution environment. Here I just added name of technology which can be used here. And then ML node load container in such virtual machine. Then it generates certificate with proof of hardware, proof of exact version and hash of software loaded. It creates temporary key pair, so private public key, which also recorded to this certificate. This key never touch disk, it's all the time in memory. And then all data which will be executed on this ML node will be encrypted with this public key. So, and then no one without knowing this key can read really user data. Yeah, and then how user will look like. Let's image that user directly interact with such ML node. It just get certificate, check that, oh yeah, it's really produced. I trust this version of software. I know that it doesn't lose any data. It for sure will require some audit or something like that. Then, yeah, user just using this public key, encrypt data with this temporary key, and then send encrypted request to such ML node. And yeah, it's encrypted only in the ML node itself, and host also cannot access it. Yeah, so that might solve the problem how to hide data from host. And moreover, if implement this, another cases which I mentioned above, this one will not be needed because the guarantee that required version of software and model weight will be also guaranteed by the version of software recorded in certificate itself. Yeah. Now there's a little architecture how the pipeline can work from client perspective. So yeah, I mentioned above, that certificate produced by ML node with certain data recorded and with certain way how to verify the certificate. Then some client just send transaction to the mainnet to get which exactly ML node it will use. And for example, create escrow in the same way how escrow created on DevShard. Then it gets back the ML node which will execute this request public key certificate. It can verify the certificate, and then it communicates directly with ML node, encrypt all data with this public key. Yeah, it's executed on this ML node, send back the also encrypted output, which will be encrypted with client pub key, but for sure on client side, no trust execution environment technology required. And then during the epoch, such ML node will just record some summary of work which it did, signed by the same key to the mainnet to kind of provide proof what it executed, what it doesn't execute, just to get paid. And essentially, only initial proof of the of this key pair will be required. Everything else, we don't need to validate this ML node. This ML node can be trusted in some way, and yeah, that's essentially how it can work. For sure, trust execution environment technology where some bugs happens, some public research happens which says that, oh, it can be broken in some way, but then Intel AMD react and fix such bugs. But also there is important that usually such ways how trust execution environment can be broken are really complicated. It requires a lot of physical resources, laboratory, just to get access to some data on disk. So it raises level of security that much, and cost of access to any bytes of information so much that it's, I think, quite secure and should be sufficient even for the real enterprise client to use inference. Yeah. Is there any question, or should I mention how it can be implemented?
I have one general comment and one on architecture. So in terms of this technology, definitely, if used just one layer of protection, some can challenge that, NVIDIA or Intel, they have keys to actually compromise the system. But knowing that Gonka is actually a decentralized network, where the request of user goes to a random hosts, I think together these two technologies can actually give a protection none of the other providers can offer right now. Moreover, most of all the requests to OpenAI or Anthropic, they completely open and can be read by the companies. So any introduction of such layer will be more protected than anything which right now used by all the developers and all agents on the market. Then on architecture, when I thought about that, and when I also looked at some of the solutions implemented in open source community, so where I see a challenge of the protocol is that if every node ML node requires a separate key, separate public key. It can be it'd be challenging to load balance and to actually work with that. So when I thought about that problem, I thought about this sequence. So if trusted execution environments can exactly prove us that this key was generated by this software, and we all can trust the software because it's open source. Then actually what we can implement, for example, even on the host level, host can synchronize the same key in between all the ML nodes, because it can have like this image, which everyone trusts, can have an option that it can accept the key from another container like that.
But then it
Checking
would
the
require
attestation,
to really check the attestation, which
yeah,
should be
but
fully optimized, and it's quite a problem in that case.
to automate attestation check.
To cover all cases, what if something happened? Because in mainnet we can kind of have the procedure when client can quickly react if something seems wrong with the attestation. Yeah.
Yeah, but without it, the load balancing will be a little bit challenging, especially then if we assume that some of the nodes will be with trust execution, some of them won't.
They might try to produce some shared key based on these keys, and for example, client wants verify certificates of group of keys.
Yeah, that's what I'm saying. So that if we have a proof just for one key, and then this key is through some protocol is synchronized between the nodes, we still can trust because we don't need to actually check the attestation of any response. If we only send
we should check attestation. We should test the attestation for every ML node, I think.
But imagine that I have attestation that this key was only inside of trust execution environments. Then I actually can just use this key to encrypt my my public key. So no one knows about, no one can actually encrypt anything with my public key without being inside of the trust execution environment. So when I get back the encrypted data, I don't even need to check attestation again, because I will know for sure that no one were able to encrypt this data with this key except being inside of trust execution environment. And it can simplify everything if we just can once check that the key is from like public key is from the trust execution environment. Then we like the rest of the process is simple. I just encrypt and send my public key, and if anyone returns the response which is encrypted with this public key, they for sure were inside of trust execution environment. So I just thought that this
From my perspective, it's important to have in mind that it should not be just in trust execution environment. It should be in trust execution environment in certain group. So it can be 1,000 ML nodes. And first, client should be able to prove that some shared key which it will use produced only by this 1,000 ML nodes. And for each separate ML nodes, it has certificate. So only to trust to certain group, but not to like general group of unknown size of trust execution environment nodes.
But if we know that trust execution environment will never share this except with other trust execution environments, we can actually still trust it in the same way without like actually even knowing the group size or things like that.
Don't agree on that, but yeah, it's probably one of points to research in
Okay.
architecture.
Yeah.
Yeah.
Yeah, sure.
Yeah. Should we anything else? Any other question? Maybe.
Pretty much unrelated, but I just wanted to point out that because I had this discussion with a couple of miners, and the question sometimes comes up, and like I want to add a clarification that implementation of TE does not mean that it will be mandatory for everybody, and it actually does not contradict any of the existing mechanisms that we have in the network. And in my opinion, that's actually very important to keep both doors opened because some of the networks actually started with trusted execution environment, and while it produces some benefits, it also adds a lot of restrictions for which hardware can be used and the setup that hosts need to have. And also, I think, like getting back to the very early point that Gleb mentioned about homomorphic encryption, keep an like open both branches of like our regular validation and trusted execution environment allows us to, like, whenever any other mechanism becomes the industry standard for encryption and privacy, we can always adopt it without like any further overhead. So that's like one small note that I wanted to add on the fact that implementation of TE on Gonka doesn't lock us and like only opens opportunities to adopt those developers and those clients that value privacy right now higher than
Performance or something.
yeah.
Yeah, so
Yeah.
in general, for sure, like I think that the concept of dev shards, which were introduced through the last two upgrades, can help us to think about it from the perspective that it just would be a kind of dev shard, which will include only hosts which support trust execution, but it doesn't mean that other hosts will anyhow be negatively affected by the process. So if developers will want to pay higher fees for privacy, then these higher fees will be received by this group of hosts. But the overall reward will not be affected by that. Meaning not overall, by block reward, like the epoch reward will not be affected by that.
Yeah, that's the idea that the certificate is designed to guarantee that this node is not. Oh, I'm answering the question in chat. So is there's opportunity that some node will just act as a ST node, but would not be really trust execution environment. Yeah, that's the idea of certificate, that it allows to prove against some root certificate which published by Intel and AMD that if certificate is produced by certain private key and signed by certain private key, and it has required data, version, state of memory, etc., then cryptographic proof that it required it's T node. So that's protect us from pretending that, yeah.
It's
At the
that
same
it's
time,
TE node and that it's running the right container. Sorry.
yes, at the same time, we actually can use other T nodes to validate. So we can have the protocol when actually I, as client, can ask the validation, and when I ask validation for another TE node, then they can reproduce and use the same validation which we right now use in the system in general. So if we in general, I would want us to build the protocol which don't trust the Intel or NVIDIA or any centralized entity as the source of truth. So from this perspective, we can use the same mechanism which we right now use for validation, but just asking other participants to validate. In general, after introduction of dev shards, this validation process is quite driven by the clients themselves. So it won't be a change of protocol to ensure that hosts within the dev shard which supports TE will validate the other hosts' work.
Also, to answer this question, so it about validate only on client side. It, in my opinion, for sure, it should be challenged. It must be validated on client side. Client must have opportunity to fully check certificate and make their own decision. If, for example, client reads some papers and client understands that some certain versions of software in this mentioned certificate might be less secure. But for sure, again, check of certificate against the root certificate published by Intel and AMD can also and should also be verified on mainnet, also on DevShard. So it's not only on client side, but there must be opportunity to verify it on client side.
So I
Yeah.
actually have a small design comment / question for the rest of you. So, one thing that can happen with DEEs is the underlying container that's running. If anything, it's doing is actually based on something outside of the TE, like something over the network, some file, some model that's hosted somewhere else. You can't necessarily prove that thing hasn't been tampered with. So are we going to be doing any kind of, like locking down of what's allowed to happen within the TE during that sort of critical time and that kind of thing?
For sure. It must be explicitly checked. For example, for models, it should all be inside the image which verified the exact weight of model and exact hash of weights which will be verified. Or it's even might be cleaner to have it in software that if it's not matching the expected hash of, for example, model weights, it must just reject. So it definitely must not rely on any external data without explicit check, because that's for sure would break all guarantee. For example, right now in non-TE ML node, it's a miner who control which exactly parameters of model will be used, which exactly model will be used, and that's not acceptable for TE. TE must, by design, have expected behavior. So it should work only with certain models, with certain way to deploy this model, to have in logic of software exact proof how it really works inside.
Yeah, I think that's a great plan. And like one thing, you can also just make it so that it like no network access is allowed while it's actually doing the thing. And there's a lot of ways to lock this down in a structural way where you don't have to worry so much about how incompetent the person who created the container is. But yeah, no, I think this is a great answer.
I'm actually quite excited to see how the developers and the users will react on this, and how like our expectations on who would want to switch to TE versus like use the regular validation would actually, you know, show in reality. Are there any more questions? So I think if not, we can probably wrap it up here. Okay, sounds like we can wrap up the session. Please, let's continue these discussions, because we discussed, I think, the very broad long-term directions and some immediate steps, like the first approximation of how implementation can look like, and like the first milestone. But as we move further, there would be many more specific questions to align on with the community. And let's keep this discussion open, please. Like, review any changes, come to the discussions on GitHub, and point out anything that doesn't look good to you, or like suggest any alternative ideas. Let's keep that open. Thanks, everybody. Have a great rest of your day.